Hi everyone, in this video I am going to solve Cambridge International AS and A-Level Mathematics Paper 1 Pure Mathematics 1 in a session October-November 2023 Paper 1-3. So let's start with the first question. Question number 1. A curve is such that its gradient at a point xy is given by, the gradient is given at some particular point. It is given that the curve passes through the point 4, 1. The curve passes through this point, then it means the curve satisfies this point. Find the equation of the curve. Alright, so we have given the information that dy over dx is equals to x minus 3 x to the power minus 1 by 2. So in order to get the equation of curve, we have to integrate both sides with respect to dx. Integrate with respect to dx. Okay, so when we integrate, the dx is cancelled with dx, derivative is cancelled with integral. We are just left with y is equals to integration of x is x square divided by 2 minus 3 integration of x to the power minus 1 by 2. Apply the power rule of integration. Minus 1 by 2 plus 1 over minus 1 by 2 plus 1 plus some constant of integration, because this is indefinite integral. Alright, now y is equals to x square divided by 2 minus 3 x, this is minus 1 by 2 plus 1, so 2 over here, 2 minus 1 is 1 by 2, 1 by 2 over 1 by 2 plus c. So y is equals to x square divided by 2 minus 3 x to the power 1 by 2. Now this is 1 by 2. Shift it to the numerator, becomes 2 by 1. The reciprocal 2 by 1 plus c. Alright. Further simplification, y equals to x square divided by 2 minus 3 times 2 is 6 x to the power 1 by 2 plus c. Okay, now to get the value for c, we have to use the point that the point 4, 1 passes through the curve. If the point passes through the curve, it must satisfy the curve, right? So we can say when y value is 1, the x value is 4. 4 square divided by 2 minus 6, 4 to the power 1 by 2 plus c. 1 is equals to, we can say 4 square divided by 2 is 8. Okay, minus 6 multiply 4 to the power 1 by 2 is minus 12. And what is 8 minus 12? 8 minus 12 is negative 4. 1 equals to negative 4 plus c. 1 plus 4 would be equals to c. 5 is the value for the constant of integration. Just substitute this c value 5 over here and you will get the equation of curve. Okay. Now then we can say the equation of the curve is y equals x squared divided by 2 minus 6 x to the power 1 by 2 plus 5. That is the equation of curve. Right. Question number 2. The circle with equation intersect the y-axis at points A and B. So when it intersects the y-axis, the x should be equals to 0. Part A. Find the y coordinates of A and B expressing your answer in terms of studs, means in square root form, right? Okay, so as we know that the circle intersect y-axis. Circle intersect y-axis. It means the x component is equals to 0 in equation of circle, right? When x is 0, we have 0 minus 3 whole square plus y minus 5 whole square equals to 40. This is negative 3 whole square plus open the square of y minus 5, a minus b whole square. This is y square minus 2 into y into 5. 2 times 5 is 10y plus 5 square is 25 equals to 40. So minus 3 square is 9 plus y square minus 10y plus 25 minus 40 equals to 0. Shift the 40 on the other side. This becomes y square minus 10y and 9, 25 and 40. 9 plus 25 and minus 40 is negative 6. Negative 6 equals to 0. Okay, now I guess it's not possible in factorization because we need to express the y coordinate in Strat's form. So apply the quadratic formula over here. So for quadratic formula, we need the values for a, which is coefficient of y square, b, which is the coefficient of y, and c is a constant term. And the quadratic formula is y equals to negative b plus minus square root b square minus 4ac divides 2 times of a. All right. Now let me substitute everything into the formula. So we have y is equals to negative, the b is minus 10, plus minus square root, b is minus 10 square, minus 4, the a value is 1, the c value is negative 6, whole divides 2 times the a is 1 and the square root. Okay, simplified further. So here we have minus 10 square and plus 4 times 6, because negative times negative is positive and 4 times 1 times 6 is the same, which is 124, and root of 124 is 3 root 2 root 31. Y is equals to 10 plus minus 2 root of 31 divided by 2. 2 times 1 is 2, right? This is root 31. Now further simplification. Okay, so y is equals to, you can take 2 common, 2 times 5 is 10, plus minus 2 times 1 is 2, so root 31 is left, and divided by 2. You can cancel the 2. Now the y coordinate is 5 plus minus root 31. We need to figure out the y coordinates in of AB in start form. So these are the two y coordinates. Y equals to 5 plus root 31, 5 minus root 31. These are the two y coordinates of A and B. So here we can say y coordinates of A and B are, so the y coordinate is y is equals to 5 plus root 31, or y is equals to 5 minus root 31. Right. Now for part B, find the equation of the circle which has AB as a diameter. Okay, so if AB is a diameter of a circle, then the midpoint of AB is the center of that circle, and from the center to the point A or to the point B, that would be the radius of the circle. Okay, so let me draw that circle. We need to figure out the equation of this circle when A and B, this line is the diameter of a circle. So for equation of a circle, we need the center of a circle and we need the radius of a circle, right? So the midpoint of AB gives you the center, right? And the distance from A to C or B to C, that would be the radius of a circle. Okay, now first thing first, we need to figure out what is the center of a circle. So for center of the circle, we need to figure out the midpoint of AB. Midpoint of AB. So for midpoint of AB, add up the x components and dividing by 2, right? So x components of A and B both are 0 divided by 2. And the midpoint for the y coordinate, add the y coordinates and divide it by 2. Y coordinates are 5 plus root 31 plus 5 minus root 31. These are the two y coordinates and divided by 2. Okay. Now this midpoint 0 plus 0, 0, 0 divided by 2, this is just 0. And this term plus minus is cancelled out. 5 plus 5 is 10 and 10 divided by 2 is 5. These are the coordinates of center of that circle. Now we need to figure out the radius of the circle, right? radius of the circle. So radius of the circle is basically the distance from A to the center or B to the center, right? So the coordinates of A we can rewrite. The A coordinates are x coordinate is 0 and the y coordinate is 5 plus root 31, and the coordinates of center are 0 and 5. Okay. Now, in order to figure out the distance, we can use the formula square root of x2 minus x1 whole square, 0 minus 0 whole square, plus y2 minus y1 whole square, and the square root. Okay, because 5 and then minus of this means this thing is minus, this both are minus, right? That is why I used the minus. So this is plus 5 minus 5 is cancelled out. Magnitude of AC would be the square root, this is 0, and plus minus root 31 square, minus root 31 and its square. Minus square is plus square and the square root is just cancelled out, so we are left with the root of 31. This is the a radius of that circle. Now let me write down what is the equation of a circle. Equation of the circle with AB as a diameter. Equation of a circle is x minus a whole square plus y minus b whole square equals to the radius square. Now A and B are the coordinates of center and R is the radius, right? So x minus A is 0 plus y minus b value is 5 equals to the radius is root 31 and its square. So the final answer is x square plus y minus 5 whole square equals to 31. This is the equation of a circle with AB as a diameter. Question number 3, part A, show that this equation may be expressed in the form cos square cos and constant, where A, B, C are constants to be found. So we need to convert everything into cos. This is in cos, this is in sine, this is in tangent. So sine and tangent are converted basically. So 5 cos theta is as it is, minus sine theta is as it is, tangent theta is sine theta over cos theta, and plus 1 equals to 0. Okay, now multiply with cos and multiply with cos. So 5, this cos is multiplied, so cos square theta, minus sine with sine is sine square theta, and 1 with cos is just cos theta. Whole thing divides with the cos theta and equals to 0, right? This is in cos, this is in cos, this would be in sine. So we have to convert it. We know that sine square theta is 1 minus cos square theta. Use this over here. Okay, so now we have 5 cos square theta minus sine square theta is 1 minus cos square theta plus cos theta equals to 0 times cos theta. I cross multiply. I did 2 steps over here. First I substitute the value of sine square theta and then I cross multiplied. Okay. Now here we have 5 cos square theta minus 1 plus cos square theta plus cos theta equals to 0. Right, now this is cos square, this is cos square, 1 and 5 plus 1 is 6. 6 cos square theta plus cos theta minus 1 equals to 0. Now this whole equation is expressed in this form: a cos square plus b cos plus c equals to 0. A value is 6, b is 1, c is minus 1, and these are the constants a, b, c. Now for part B, hence solve the equation. Okay, we need to put this equation equals to 0 for theta is between 0 to 2 pi. The domain for theta is in radians, right? So we know that this whole thing is similar to this, right? It can be expressed in that form. So we can say this equation can be written as 6 cos square theta plus cos theta minus 1 equals to 0, right? Now, it is a quadratic equation in cos, so we can factorize it, right? 6 times minus 1 is minus 6. We can say 2 times minus 2 times 3 is minus 6, and when you do minus 2 plus 3, this will gives you 1. We need to break the midterm with negative 2 and positive 3. 6 cos square theta minus 2 cos theta plus 3 cos theta minus 1 equals to 0. Now we can take 2 common and cos theta common. So we are left with 2 times 3 is 6 and cos theta negative 1. So 3 cos theta minus 1 is already here. So just take plus 1 common. So 3 cos theta minus 1 equals to 0. So these are the factors. 3 cos theta minus 1 is a factor and 2 cos theta plus 1 is a factor. 2 cos theta plus 1 equals to 0. Now put both factors separately equals to 0. Here we have 3 cos theta minus 1 equals to 0, or we can say 2 cos theta plus 1 equals to 0. So from here 3 cos theta is equals to 1 and cos theta is equals to 1 by 2. Sorry, 1 by 3. And 2 cos theta is equals to negative 1, and here cos theta is equals to negative 1 by 2. So here cos is positive and here cos is negative, and the domain we have given is from 0 to 2 pi, means the whole circle. Now let's see in which quadrant cos is positive and in which quadrant cosine is negative. Okay. Before that, let me find out the base angle for both. The base angle for this case and the base angle for this case. So whenever we are going to solve for the base angle, we are not considering the signs, right? So here theta would be equals to cos inverse of 1 over 3. And here theta is equals to cos inverse of 1 over 2. Do not consider the negative sign for the base angles, right? Now your calculator should be in radians. This is in degree mode. Let me convert it into radians, right? Now we need to figure out what is cos inverse 1 over 3, which is theta is equals to 1.231 radians. And here cos inverse of 1 by 2 is pi by 3. Theta is pi by 3. Okay. Now let me draw the coordinate diagram and see where the cosine is positive and where it is negative. Okay. All right. Now in first quadrant, all trigonometric ratios are positive, sine positive, tangent positive, and cos positive, right? Here we do theta, here we do pi minus theta, here we do pi plus theta, and 2 pi minus theta, and this theta is basically the base angle, right? Okay, now cos, this equation says cos is positive. Cos is positive in first and fourth quadrant, and here say cos is negative. Cos is negative in second and third quadrant, right? Okay, now here we can say this equation cos is positive. Cos is positive in first quadrant and in fourth quadrant. Okay, first and fourth, right? So what is operation for the first quadrant? For first quadrant, we do the base angle. What is theta value? Theta value is the base angle, which is this is the base angle. So here theta is the base angle 1.23 radians. Now for the fourth quadrant, what is theta? Theta is your 2 pi minus the base angle. 2 pi minus the base angle. Let me figure out 2 pi minus 1.23. This is 5.05. Okay, here theta is 5.05. So these are the two solutions when cos is positive. Now we have the second case when cos is negative. Now here you can see cos is negative in second and third quadrant. So we can say cos is negative in second quadrant and in third quadrant. All right. Now for the second quadrant, what is your answer for theta? Pi minus base angle, pi plus base angle. This is a base angle pi by 3. Okay. So theta would be equals to pi minus the base angle, and here theta is equals to pi plus the base angle. Okay. So pi plus pi by 3, 3 is over here. 3 minus 1 is 2. So 2 pi by 3, right? And the other is, this is 3. 3 plus 1 is 4. So 4 pi by 3. These are also the two solutions. 2 pi by 3 or 4 pi by 3. So these are the four required solution when the theta is between 0 to 2 pi. Question number 4, part A. Expand the following in ascending powers of x up to and including the term of in x square, right? Ascending powers of x are basically the increasing powers of x to the increasing powers, like x to the power 0, x to the power 1, x to the power 2, and so on. So we need to expand in ascending powers of x up to and increasing the term in x square. Till x square we need to expand it. So the first one is 1 to the power 5 plus 5c1, 1 to the power 4, 2x to the power 1 plus 5c2, 1 to the power 3 and 2x to the power 2, and so on. So we need to expand till x square, right? 1 to the power 5 is just 1, right? What is 5c1? Which is 5. 5c1 is 5. 1 to the power 4 is 1 and 2x. Plus 5c2 is 10. 10, it's 1 cube is 1, 2 square is 4x square. So this implies the final answer is 1 plus 5 times 2 is 10x. 10 times 4 is 40x square. This is the final expansion to x square. Okay. Now for the second part, where a is a constant we have given. So let me expand it till x square. 1 to the power 6 plus 6c1, 1 to the power 5, negative ax to the power 1, plus 6c2, 1 to the power 4, minus ax to the power 2, and so on. This is x squared term. Okay, now 1 to the power 6 is 1, 6c1 is 6, this is 1, and this is minus ax. What is 6c2? 6c1 is 6 and 6c2 is 15. 15, 1 to the power 4 is 1, minus it becomes plus x square, a square, and x square. Minus square is 1, minus square is positive, and a square x square, right? Now this becomes 1 minus 6ax plus 15 a square x square. This is expansion till x square. All right. And the expansion of these two, the coefficient of x square is negative 5. Part B, find the possible values of a. Values means more than one value, right? Okay, so we have expanded this in first part and this in second part. So let me open the expansion. 1 plus 10x plus 40x square for the first one, and its product with 1 minus ax and plus 15 a square x square, right? So first product with 1, so it is a constant x and x square term, right? So we need to just pick the x square terms, right? X square terms. So in x square terms, 1 is multiplying with 15 a square x square. You will get x square term 10x. This is x term, this is x square term, plus 10x is multiplying with minus 6ax. You will get x square term. Now this is x cube term. This x square is multiplying with 1. You have x square term. 40 x square is multiplying with 1. Now these are x cube term. These are x to the power 4 term. So here we have 15 a square x square. 10 times 6 would be 60 a x square plus 40 x square. Okay. All right. Now we have to pick the coefficient of x square. 15a square minus 60a plus 40. These are the coefficients of x square, right? This coefficient of x square is negative 5. So we have given that x square coefficient is minus 5. So we can say 15a square minus 60a plus 40. This is negative 5. All right. Now just simplify. So 15a square minus 60a plus 40 plus 5. Shift the 5 on the other side. 15a square minus 60a plus 45 is equals to 0. All the terms are divisible by 5. Let me divide everything by 5 on both sides. Okay. So 5 times 3 is 15. 5 times 1 is 5. 5 times 2 is 10. 5 times 9 is 45 and 0. Now everything is divisible by 3. Divided by 3. Divided by 3. Divided by 3. 3 times 1 is 3. 3 times 4 is 12. 3 times 3 is 9 equals to 0. Now this is a quadratic equation in a variable a. We need to factorize it. 1 times 3 is 3. And when you do minus 1 minus 3 gives you negative 4. So break negative 4. A square minus a minus 3a plus 3 equals to 0. Take a common, we are left with a minus 1. Negative 3 is common, a minus 1 equals to 0. When you took a common, 1a is left and negative this a is common, so 1 is left. Negative 3 is common, so this a minus 3 is already common, we are just left with a. So minus 3 is common, so negative 1 is left. Factors are x a minus 1 and a minus 3 equals to 0. So put both factors separately equals to 0. So from here a minus 1 equals to 0. A minus 3 equals to 0. So from here the a value is 1 and here the a value is 3. So these are the two possible values of a, which is 1 and 3. Question number 5. The first, second and third term of a geometric progression are first, second and third respectively. Part A. Find the possible values of a constant p. So if it is a geometric progression, it has a common ratio. For geometric progression, it has a common ratio. Common ratio means the second term over the first term should be equals to the third term over the second term. Okay. Use this. Now the second term is 5p divides the first term is 2p plus 6 equals to the third term over the second term. We need to find the possible values of the constant p cross multiplied. 5p is multiplying with 5p. 8p plus 2, this thing is multiplying with 2p plus 6. This is 5 times 5 is 25, p times p is p square. Now 8p is multiplying with the bracket. So we can say 8p with 2p plus 6 and positive 2 is multiplying with 2p plus 6. This is 25p square. 8 times 2 or 2 times 8 is 16. P times p is p square. 8 times 6, 48 p. 2 times 2, 4p. 2 times 6 is 12. Now this is 25p square minus 16p square. Shift everything to the left, right? This is negative now. This is also negative. This is negative. And this is also negative equals to 0. Now from 25 take away 16. That is 9. So we have 9p square. Minus 48 and minus 4 is minus 52. P and minus 12 equals to 0. Okay, now let me factorize this. 9 times 12, 108. Factors of 108. Okay. I guess the factorization is hard, so let me apply the quadratic formula. So P is equals to minus B plus minus square root B square minus 4AC divides 2A. So what is A, B, and C? A is a coefficient of P square, which is 9. B is a coefficient of P, which is minus 52, and C is a constant term, which is negative 12, right? So substitute everything into the formula. P is equals to negative B is minus 52 plus minus square root B values minus 52 square minus 4, the A is 9 and C is minus 12, whole divides, and the square root 2 times the A is 9. So P is negative times negative is positive 52 plus minus square root. What is 52 square? Minus 52, its square is this, and plus 4 times 9 times 12. Negative times negative makes positive is this, and what is root of 56? Okay. 3136, and root of this is 56. Okay. Divides 2 times 9 is 18. So P would be equals to 52 plus minus 56 over 18. Square root is 56, right? Okay, now we have two values for P. P is equals to 52 plus 56 over 18, or P is equals to 52 minus 56 over 18. All right. Now we have 52 plus 56 divided by 18 is 6. Okay. 52 minus 56 divided by 18 is minus 2 by 9. So these are the two possible values of P. The first value of P is 6 and the second value of P is minus 2 by 9. Now for part B, one of the values of P found in A part is a negative fraction. Yes, it is a negative fraction. You can see this is a positive and this is a negative fraction, minus 2 by 9. So this value of P is negative 2 over 9. Use this value of P to find the sum to infinity of this progression. We need to figure out S infinity. So S infinity is equals to A over 1 minus R. Okay. So what is A? A is the first term, which is equals to 2P plus 6. Now 2, the P value is minus 2 by 9 and then plus 6. Right. So 2 into minus 2 over 9 plus 6 is 50 over 9. This is your first term. And R is the common ratio, which is the second term, 5P over the first term, 2P plus 6. 5P is 5 into minus 2 by 9. And 2P plus 6 we have done, which is 50 over 9. Okay. Now 5 into minus 2 over 9 is minus 10 over 9 over 50 over 9. 9 is cancelled with 9, right? Negative 10 divided by 50 is 1 minus 1 over 5. Minus 0.2, right? So for common ratio, we have a restriction that our values should lies between minus 1 and plus 1. So this is minus 0.2, it is in the range. Okay, now figure out S infinity. S infinity is the first term, which is 50 over 9 over 1 minus R is minus 1 by 5. So this is 50 over 9 over 1 plus 1 over 5. 1 plus 1 by 5 is 6 by 5. 50 over 9 divides 6 over 5. So S infinity is 50 divided by 9, multiply the reciprocal of 6 by 5 is 5 over 6, right? Okay, 50 divided by 9, multiply 5 by 6 is 125 over 27. This is your S infinity, the sum to infinity for this progression. for that specific value for P. Question number 6. A line has equation and a curve has equation where C is a constant. The line is tangent to the curve at P. Okay, the line is tangent to the curve. When the line is tangent to the curve, it means the line touched the curve at one point, because tangent touches at one point. Find the possible values of C and the corresponding coordinates of P. Okay, line is tangent to the curve. It means when line is tangent to the curve, then the line touch the curve at one point. So we have one point of intersection, one solution. So discriminant is equals to 0, right? Okay, so the curve is cx square plus 2x minus 3 equals to the line is 6x minus c. Cx square plus 2x minus 3 minus 6x plus c equals to 0. Cx square, 2x and minus 6x would be minus 4x, and plus c minus 3 would be the constant term. Okay, now for one point of intersection, we can say for one point of intersection, discriminant should be equals to 0. Okay, so what is the discriminant? A is the coefficient of x square, B is the coefficient of x, and C is the constant term, which is C minus 3. Okay. So B square minus 4A and C equals to 0. 4 times 4 is 16, minus 4 C's multiplying with C minus 3. 16 minus 4c with minus 4c square, minus times minus is plus, 4 times 3 is 12, c equals to 0. Okay, all the terms are divisible by 4. Divide everything by negative 4, divide by negative 4, divide by negative 4, divided by negative 4. Okay, 4 times 4 is 16, so negative 4 plus c square, 4 times 3 is 12 and 0. Or we can say c square minus 3c minus 4 equals to 0. Now we can easily figure out the possible values of c, right? Okay, so factorize it, write the midterm. 1 times negative 4 is negative 4, and when we do 1 minus 4, you will get negative 3. So break negative 3 to 1 minus 4. C square minus c minus 4c minus 4 equals to 0. C is common, c minus 1 is left. Okay. Wait a second. 1 is plus. Okay. Now negative 4 is common. Now c plus 1 is left. C plus 1 is a factor and c minus 4 is the factor equals to 0. Now both factors are separately equals to 0. C plus 1 equals to 0 and c minus 4 equals to 0. Now the two possible values of c are negative 1 and positive 4. These are the two possible values of c. C is negative 1 and c equals to 4, right? Okay, now we have done with the two possible values of c. Now we need to find the corresponding coordinates of p, means the x and the y coordinate of point of intersection of the curve and the line. So this is a curve and this is a line. We will get this equation. Okay, so here substitute the first value of c and solve, and the second value of c and then solve. You will get the two possible coordinates of p. Okay. So the first case is when c is equals to negative 1. So this is the equation static. Put c value minus 1 over here. So c is minus 1, so minus x square minus 4x plus minus 1 minus 3 equals to 0. Minus x square minus 4x minus 4 equals to 0. Take negative sign common, x square plus 4x plus 4 equals to 0. So now x square plus 4x plus 4 equals to 0. You can cancel, multiply with the 0, the negative, so it's 0. it's positive, right? Okay, now this is x square plus 2x into 2 plus 2 square equals to 0. A square plus 2ab plus b square. This is x plus 2 whole square. Okay, or taking a square root on both sides to solve for x. This is with plus 0 and minus 0. So x plus 2 would be equals to 0. The x coordinate is negative 2. When the x coordinate is negative 2, just substitute the x and the c value in the line, you get the y coordinate. Put x is equals to minus 2 and c is equals to minus 1 in equation of line. We will get the y coordinate 6 into minus 2 minus the c is minus 1. So y would be equals to 6 times 2 is negative 12 plus 1, which is negative 11. You will get the y coordinate, right? So we can write down the first case when c is minus 1. The point x and y coordinates are x is minus 2 and the y is negative 11. Okay, so these are the first possible coordinates for point P, right? Now we need to figure out for the second one when the C value is 4. Just substitute C value of 4 in this equation, right? So here we can say when C equals to 4, the equation becomes, just substitute 4 over here, 4 x square minus 4x plus 4 minus 3 equals to 0. Let me simplify. 4x square minus 4x plus 1 equals to 0. Okay, now we can say this is 2x whole square minus 2a and b. What is the b? B is 1, because 2x whole square would be 2 square is 4x square is x square, 4x square minus 2 into the first term into the second term. So this is minus 4x plus the b square. This is a square minus 2ab plus b square. This is 2x minus 1 whole square equals to 0, or 2x minus 1 equals to 0, and here 2x would be equals to 1, and from here the x coordinate is 1 over 2. When the x coordinate is 1 by 2 and the c value is 4, just plug everything into the equation of line y equals to 6x minus c. Now from here the y is equals to 6x minus c. The y coordinate is 6 into x is 1 by 2 minus the c value is 4. Okay, so 2 times 3 is 6. 3 minus 4, this is negative 1. The y coordinate is negative 1. So the second case we can say when c is equals to 4, the coordinates of the point P, the xy coordinate, the x coordinate is 1 by 2 and the y coordinate is negative 1. So these are the coordinates for point P. This is the coordinate for point P. Question number 7. The function f is defined by f of x is this function. For x is greater than 2, the domain is greater than 2. Part A, state the range of f. It is a 1-mark question. So we need to figure out the range of f. For this, let me visualize everything, right? So I want to draw the graph. So first we need to figure out what is the base function. So as we know that the base function is y equals 1 over x. So first we need to plot the graph of y equals to 1 over x, right? Okay. So here is the graph of y equals to 1 over x. All right. Now, this x is subtract 2. Now, the second is, this is a base function. Now, when you have x minus 2, what happened? It means we have a horizontal translation 2 units to the right. So, horizontal translation 2 units right. which is y equals to 1 over x minus 2. Okay, so let me draw this. We have to move everything 2 units to the right. Okay, so let's say this is x is equals to 2. This line is x is equals to 2. So this graph shift 2 units to the right, and this also shift 2 units to the right. Okay, now it has some y-intercept. So what is this y-intercept? When x is equals to 0, the y-intercept is minus 1 by 2. This is minus 1 over 2. Okay, that's the y-intercept. Now the next transformation we have applied is multiplying with 3, right? So multiplying with 3, it means we have a stretch, the stretch in y direction by a factor of 3, right? So we can say the vertical stretch by a factor of 3. Y would be equals to 3 over x minus 2. So this whole function is multiplying by 3. Means the y coordinates are multiplying by 3, the x coordinate stays the same. Okay, let me sketch the graph for this. Let us suppose this is a line. X is equals to 2. Okay, and it stays the same, just the y coordinates, this is a y coordinate, it is multiplying by 3. Now the y-intercept is minus 3 by 2. Minus 1 by 2 is multiplying by 3 is minus 3 by 2. Stretch in y direction, it means y coordinate are multiplying by 3. Just the y coordinates, right? Now the next thing we can see, 1 is added. It is a horizontal. We have a vertical translation, 1 unit up. Horizontal translation, 2 units, right? I forgot to write down 2 here. Okay, now y is equals to 1 plus 3 over x plus 2. Okay, so we have to move everything 1 unit up. All right, this is your final graph, right? So here we have x is equals to 2, and here we have y is equals to 1. This line is y equals to 1. You have to shift everything 1 unit up, and we have to shift this thing 1 unit up. It means 1 minus 3 by 2. Minus 3 by 2, just add 1. Here we have 2 minus 3 by 2, which is minus 1 by 2 is your y-intercept. Minus 1 by 2 is over here. This is how the graph look like. Now, for this final function, what is the range? The domain we have given, the x values, the domain is x is greater than 2. You can see the x values are, okay. Wait, when x values are greater than 2, here you guys can see, we can say when x is greater than 2, this is x is equals to 2, and these values are x is more than 2. So we have two part of the graph. We are just dealing with this part of the graph. This section tells us that x is greater than 2. So when x value is greater than 2, what happens to the y values? Y values are more than 1. So we can say y values are greater than 1. So this is y equals to 1, y values are more than 1. That would be the range of the function. Okay, so for the range is when x is greater than 2, range of f is y values are greater than 1, as you guys already see. Okay. Now for the second part, obtain an expression for f inverse and state the domain of f inverse. All right. So for f inverse, we need to put y equals to the function f of x. So here we can say y is equals to f of x is 1 plus 3 over x minus 2. Now the next step is you have to switch the variables, right? Y switch with x, 1 plus 3 over x, which is with y minus 2. Next step is to solve for y. Okay, so x minus 1 would be equals to 3 over y minus 2. Now cross multiplied means switching the positions, right? This over here and this over here. So y minus 2 would be 3 over x minus 1, or you can say y would be equals to, shift the 2 on the other side, 2 plus 3 over x minus 1. This expression is for your f inverse of x. This y is your f inverse of x. So the first thing is to figure out what is your f inverse of x, and the next step is to figure out what is the domain of f inverse of x. Okay. Now the domain of f inverse of x is basically, we know that the domain of f inverse is equals to the range of f. So what is the range of f? Range of f is y is greater than 1. So this implies the domain of f inverse is x is greater than 1. This is the domain for f inverse. Right? Now for the next part, the function g is obtained by, this is your g of x for x is greater than 0. Part c obtained a simplified expression for g f of x. Okay. Right, g and f of x. We have g and f of x is 1 plus 3 over x minus 2. And g of x is 2 into this expression minus 2. Now just simplify it. Okay, so this is 2 times 1 is 2, 2 times 3 would be 6 over x minus 2 and minus 2. Alright, 2 and minus 2, these two are cancelled out. Yeah, and the simplified expression for g f of x is 6 over x minus 2. This is a simplified expression. Alright. Question number 8. The diagram shows the part of the graph of y equals to sine a into x minus b, where a and b are positive constants. Keep it in mind, they are positive, right? Part A, state the value of a and one possible value of b. Okay, so this a and this b, these are basically two transformations. The a deals with a stretch in x direction and b deals with the horizontal translation in x direction, right? Both are in x direction. So as you can see, the base function for this is y equals to sine x. Let me graph y equals to sine x, the base function. Okay, so this is a base function. One complete cycle is 2 pi. This is 0. This is pi. This point is 1. This point is negative 1. And here we have pi by 2. And here we have 3 pi by 2. Okay. Now this is from 0 to pi, the half cycle. And they are also dealing with the half one. So I'm just going to plot the half cycle here. Okay, so from 0 to pi. Yeah, this is the pi, this is 0, and in the middle we have pi by 2, and the maximum point is 1. It has a maximum point 1. So if I can just plot the from 0 to pi, right? This is from 0 to pi and pi by 2. This is pi by 2. Between pi by 3 and 2 pi by 3, it is pi by 3 is 60 degree and 2 pi by 3 is 120 degree, and the 60 and 120 midpoint is 90 degree, which is pi by 2, right? So if I can sketch this, it has a maximum point at 1. Yeah. So this is a sketch for y equals to sine x. This is the base function y equals to sine x. Okay, so 0, pi, and these 2 points are pi by 2. So from pi by 2, its value is just 1. So this sketch and this sketch. Okay, so the first transformation, we have to apply the series or follow the order of transformation, right? So the first order is this a value, which is the the horizontal, the horizontal stretch, the stretch in x direction, right? So A is basically the stretch in x direction. X direction by a factor of, we don't know the factor, right? We need to figure out. So keep it in mind when we have the translation in x direction, any translation, whether it is a stretch in x direction or we have a transformation in x direction, we have to do the reverse, right? So we have a stretch in x direction, it is a reciprocal, it's multiplied, so we take its divide. And we have a horizontal translation, it's plus, so we take minus, right? Okay. Now stretch in x direction by a factor of 1 over something, right? The reciprocal of the stretch. And for horizontal translation, if you move towards right, you have to take it negative, and towards left you have to take it positive, right? Okay. Now when we have, you can see this stretch, and when we stretch something from 0 to pi, it extend, right? Okay, so this is pi and this is 2 pi. Okay, everything extends by a factor, means every we have a stretch in x direction by a factor of 2, but we need to write down the a value, the reciprocal of 2, which is 1 by 2. As I told you, for x transformations, whether it is a stretch or a translation, we do the opposite, right? Multiplication opposite is division, addition opposite is subtraction, right? So this value is pi, this is 0. So if I multiply everything, you can see now this is 1, 2, and 3 units, right? And this graph is 1, 2, 3, 4, 5, and 6 units, right? So from this point to this point, this is just 3 units distance. And from this point to this point, we have 1, 2, 3, 4, 5, and 6 units, right? So this distance is 3 units, right? And this distance is 6 units. So what does it means? Means 3 is multiplying by 2, you will get 6. 3 times 2 makes 6. Means every x coordinate is multiplying by 2, right? X coordinate is multiplying by 2. So we have a stretch in x direction by a factor of 2, but we need to take a reciprocal of 2, which is 1 by 2. So we got the a value, which is 1 by 2. So let me multiply every x coordinate by 2, right? So 0 is multiplying by 2, gives you 0, right? Now this is my next x coordinate, which is pi by 2. So pi by 2 is multiplying by 2, you will get pi, right? So at pi by 2 is multiplying by 2 is pi, right? At pi, the x, this is equals to 1, right? I hope you understand. The first x coordinate is 0, 0 times 2 is 0, right? First x coordinate is 0 and 0. The second, we can say this point and this point we can take for the base function. At pi by 2, its y value is 1, and at pi, this is again 0. Okay, so when every x coordinate is multiplying by 2, 0 times 2, the y coordinate is same. Pi by 2 times by 2, the y coordinate is same. Or pi is multiplying by 2, the y coordinate is same. So it turns to 0 times 0 is 0. And this 2 is cancelled out, pi 1. And this is 2 pi and 0, right? Now the new coordinates are, this is 0, 0. Now at pi it is 1. This point is the new one. And at 2 pi it is 0. 2 pi it is again 0. So this would be the sketch. Let me sketch it with the green color to differentiate it. After applying a stretch in x direction by a factor of 1 by 2, you will get this stretch, right? Or if I can extend it, this, and extend this. Okay. Now what happened? This point moves to this point. Every point move some units to the left. We have a stretch, we have a translation in uh, vertical. It is a horizontal translation, but towards left. Now, this b value is basically the horizontal translation. So keep it in mind that when the horizontal translation is towards left, the b value is when the horizontal translation is towards right, the b value we take it negative. And when the horizontal translation is towards left, we have to take the b value positive. Means for the left, the b is positive b value. And when we have towards right, we have to take negative b value. Okay. Same is the case for the stretch in x direction. Since the stretch in x direction is by a factor of 2, means every x coordinate is multiplying by 2, but we have to take a reciprocal. The a value is 1 by 2, right? Okay. Now, as you can see, when you move every point, 0 moved pi by 3 units to the left, right? So we have a horizontal translation pi by 3 units left. You can see when you move pi by 3 units to the left, this 0 pi by 3 units to the left, 2 pi minus pi by 3, you will get this, right? You guys can see 2 pi minus pi by 3, 5 pi by 3, right? Okay, so we have to move every point pi by 3 units to the left. And when we are moving to the left, this implies the b value is positive pi by 3. When we are moving to the left, the b value is positive. When to the right, the b value is negative. Now, this implies the b value is positive pi by 3, and the a value is, from here the a value is pi by 1 by 2. So we have a stretch in x direction by a factor of 2, but the a value is 1 by 2, right? And we have a translation, the horizontal translation pi by 3 units left, but we have to consider it positive pi by 3. That is why they said a and b are both positive constants. A is 1 by 2 positive, and b is pi by 3, both are positive. I hope this is clear now. Moving to the second part, another curve with equation y equals to f of x has a single stationary point. Single stationary point. Stationary point is basically the turning point at the point PQ, where P and Q are constants. The curve is transformed to the curve with equation. Okay, it is transformed to this equation. Part B, for the transformed curve, find the coordinates of the stationary points, giving your answer in terms of P and Q. Okay, this is a totally different question from A part. The original coordinates are, okay, we can say the stationary point, the coordinates are P and Q, right? These are the coordinates for PQ for y equals to f of x. This is for y equals to f of x. Okay. Now, f of x, we have some series of transformations applying on f of x. The first one is we have a reflection in x-axis, we have a stretch in y direction by a factor of 3, we have a stretch in x direction by a factor of 4, and we have horizontal translation 8 units left, because 8 is positive, so we have to move left, right? Okay, so let me apply those transformations one by one. So the first transformation we can apply is a reflection in x-axis. When we do the reflection in x-axis, then how can we change y would be equals to minus f of x, right? The y values are only changes, right? So pq changes to p and minus q when we do the reflection in x-axis, right? Now the second transformation, you guys can see we have some 1 by, this is 3, sorry, 3, yes, I forgot 3. So the second transformation is we have a stretch in y direction. Stretch in y direction by a factor of 3, right? Means your y would be equals to minus 3 times f of x. Means the y coordinates are just multiplying by 3. Now this p and minus q turns to p and minus 3q when we have a stretch in y direction by a factor of 3. Okay, so we have done with minus, we have done with 3. Now what is this 1 by 4? 1 by 4 is a stretch in x direction by a factor of 4. The third transformation is a stretch in x direction by a factor of 4. By a factor of 4. And y would be equals to minus 3 f of 1 over 4x. Okay, means the x values are multiplying by 4. So now p and minus 3q changes to 4p and minus 3q stays the same. Just the x values are multiplying by 4. Right? Okay, now the third last thing we have, the fourth transformation here is, now this is the 8. This 8 tells us the horizontal translation 8 units left. So we have a horizontal translation 8 units left. So y changes to minus 3 f of 1 over 4 x plus 8. Okay. Now this 4p and minus 3q, this coordinate changes to horizontal translation means just deals with x coordinate, just subtract 8 in x coordinate. 4p minus 8 and minus 3q, these are the new coordinates. These are the stationary point for the transformed curve. I hope this is clear now. So the first thing, we have a reflection in x-axis. The y coordinate is reverse. Then we have a stretch in y direction by a factor of 3. Y coordinate is multiplying by 3. Then we have a stretch in x direction by a factor of 4. The x coordinate are multiplying by 4. And keep it in mind, I told you in part A that when we have a stretch in x direction, we have to do the reverse by a factor of 4, so it is 1 by 4. Write down 1 by 4. And then we have a horizontal translation 8 units left. It's positive 8, so keep it left minus 8, right? Okay. Question number 9. A curve has equation. This is equation of the curve. Part A. Find the equation of normal to the curve at a point A, giving your answer in the form of y equals to mx plus c. Equation of normal to the curve. For equation of normal to the curve, we need the point, which is 4, 3, and we need the gradient of the normal, right? So what is the gradient of the curve? Gradient of the curve is dy over dx. So 2, the derivative is power rule, power base power minus 1, and 0, 1 derivative is negative, 1 derivative is negative 0. 2 is cancel out with 0 here, x value is minus 1 by 2, or its derivative is 1 over root x, right? Now what is the gradient, what is dy over dx at the point A, which is 4, 3, when x is equals to 4? 1 over root 4, which is 1 over 2, right? 1 by 2 is the gradient of the curve. Okay, now the next thing is, what is the gradient of normal? Gradient of normal is negative and the reciprocal of the gradient of the curve 1 by 2, which is negative 2. So gradient of normal is and the gradient of curve, both are perpendicular to each other, right? So the gradient of normal is negative and the reciprocal of the gradient of the curve, right? Now we have the gradient, we have the point, just write down the equation of normal. Now the equation of normal is y minus y naught is equals to m into x minus x naught. X naught and y naught is the point A and m is the gradient. So y minus 3 is equals to negative 2 into x minus 4. But we need to convert it into this form. Okay, so here we have y minus 3 is equals to minus 2x and plus 2 times 4 is 8, and y would be equals to minus 2x plus 8 and plus 3. Shift the 3 on the other side. So y is equals to minus 2x plus 11. This is the uh, equation of normal to the curve at a point A in the form of y equals to mx plus c form. Now, for the second part, a point is moving along the curve. Along this same curve, a point is moving in such a way that at A, the rate of increase of the x coordinate is 3 centimeter per second. Rate means the derivative of x coordinate with respect to time. So, but we have given that dx over dt, this is equals to 3. Part B, find the rate of increase of y coordinate at A. We need to figure out what is dy over dt. Dy over dt is basically dy over dx multiply dx over dt, the chain rule. This is basically the chain rule. This is a chain rule. Dy over dt and dx is over here. We need to figure out what is dy over dt at A, right? Okay, so dy over dt at A, which is 4, 3, we need to figure out dy over dx at A. This is dy by dx at A, which is 1 by 2, 1 by 2, multiply dx over dt at A is 3. So this is 3 by 2. All right. So the answer is 3 by 2. Okay. Now for the third part, at A, the moving point suddenly changes direction and speed. It changed the direction and speed, moves down the normal in such a way that the rate of decrease of the y coordinate is constant at 5 centimeter per second. Means the derivative of y with respect to time is negative 5 because it is decrease. Part C, as the point moves down the normal, find the rate of change of its x coordinate, dx over dt. So here we need to figure out what is dx over dt. So dx over dt is dx over dy multiply dy over dt. This is again a chain rule. Okay. Now, as you can see, as the point moves down the normal, now the point moves on the normal, not on the curve, right? We can say since the point moves on the normal, equation of normal. And we have done with equation of normal, which is y equals to minus 2x plus 11. So what is a gradient of normal? So we need to figure out this, what is dy over dx of normal, which is negative 2. So we have to use this information, right? So here dx over dy. So what is dx over dy for the normal is negative 1 by 2, the reciprocal, right? So just substitute over here. This value is given, which is minus 5, and you will get the rate of change of its x coordinate. So here we have dx over dt. This becomes dx over dy is minus 1 by 2, and dy over dt is negative 5, right? Just substitute over here negative 5. Negative times negative is positive, and here we can get dx over dt is equals to 5 over 2. This is a rate of change of x coordinate with respect to time. Okay, so basically in this question, the main thing is when the point is not moving along the curve, the point is moving along the on the normal. So we have to use the equation of normal. But in part B, you guys can see the point is moving along the curve, so you have to use equation of curve, use the gradient of the curve. Now in this part, you have to use a gradient of normal, right? Question number 10. The diagram shows points A, B, and C lying on a circle with the center O and radius R. Okay, the point A, B, and C. These point lies on the circle with the center O, and the radius of a center is R. O to A is R, O to C is R, O to B is R. Angle AOB is 2.8 radians. The shaded region is bounded by two arcs. This is a shaded region, it is bounded by two arcs. The upper arc is a part of a circle with the center O and radius R. This is a part of a circle with the center O and the radius is R. And the lower arc is a part of a circle with the center C and radius is capital R. This lower arc is a part of another circle whose center is C and the radius is capital R. Means C to A is capital R and C to B is also capital R. This is small r. Okay. Now for part A, state the size of angle ACO in radians. A, C, and O. This angle we need to measure. All right. So first of all, we know that if we consider a circle with the center O, this angle is 2.8 and the whole would be 2 pi, right? This whole angle is 2 pi, right? So as we know that from 2 pi, if you subtract 2.8, okay, in radians, 2 pi minus 2.8, the angle is 3.48 radians. This angle is 3.48 radians. 3.48 plus 2.8 gives you 2 pi, right? But as you can see, this triangle AOC and BOC, these two triangles are symmetrical, right? So this angle and this angle both are equal and the half of it, 1.741, or we can say 1.74. This angle is also 1.74. Okay, if I consider this triangle AOC, this is an isosceles triangle. This length is R, this length is R, right? Two sides are same, two angles must be same. So this angle and this angle must be equal, right? Okay, now here we can say consider triangle AOC, isosceles triangle. This is an isosceles triangle because two sides are same, two angles must be same, right? So if I can draw this triangle separately over here, you guys can easily understand what I'm trying to say. So this is a triangle A, O, and C. This side length is R, this side length is R, this angle is 1.74. So these two angles are also same. For isosceles triangle, two sides are same, two angles are same. Let's say this angle is X and this angle is X. Okay. So sum of all angles of a triangle add up to 180. Sum of all angles in triangle adds up to 180 degree. So let's say the two angles are x plus 1.74. Their sum is 180 degree, means pi. In terms of radian, we have to consider it pi or pi. Okay, so here 2x would be equals to pi minus 1.74. So I added the x to x and shift the 1.74 on the other side. So we can say pi, subtract the answer. This is 1.4. So what is x? X is 1.4 divided by 2. Divided by 2. zero point 0.7. So this is 0.7 radians. So the size of the angle ACO is 0.7 radians. This is the size of the angle ACO. Let me write it down. This angle is 0.7. This angle is also 0.7. All right. Now for part B, find capital R in terms of small r. Okay, here is a capital R and here is a small r. We need to figure out capital R in terms of small r, all right? All right, so again, if I consider this triangle AOC, this side length is R, this side length is R, this side length is capital R, these two angles, and we know all the three angles and the sides. So we need to solve capital R in terms of small r. So if I apply law of cosine, right? Law of cosine on triangle A, O, and C. Okay. So according to law of cosine, we have a side r square. We know this angle. R square equals to the square of the other two sides, which is small r square plus small r square minus 2 into small r cos of the angle, which is 1.74. The law of cosine. So this r square equals to the square of this side, square of this side, minus 2, the product of these two sides, multiply cos of the angle of this side, right? Now this is r square and this is 2r square minus 2r square. What is cos of 1.74 in radians? This is in radians. Now cos 1.74, this would be negative 0.17, right? Now r square is 2r square. Now this term multiply with negative 2 and you will get positive 0.34 r square. Now r square coefficients we can simplify, add up with 2. So small r, capital R square is 2.34 r square, right? Now the square root on both sides. So capital R square square root. This is a square root of 2.34 r square, and you know that when we do the square root on both sides, the answer is in plus and minus, but here we consider only plus. Why? Because this is the radius of a circle with a center C, and radius never be negative. And from here this is cancelled out, this is cancelled out. What is root of the answer? 1.528 or 1.53. So capital R is 1.53 of small r. This is expression of capital R in terms of small r. All right. Now for part C, find the area of the shaded region in terms of R. Okay. The shaded region. This is a shaded region. Okay, so what is this shaded region? Tell us. Okay. So basically, we have to figure out the area of the sector AOAB, area of this sector. From this sector area, we need to subtract this area. What is that area? Okay, so that area we can consider another sector, this sector CAB, this sector, minus these two triangles. You will get area of it, right? So here we can say the shaded area is area of a sector OAB, area of this sector O, A and B, this whole sector area, but this is not shaded, so we have to subtract this, minus area of segment, right? This is, we can say this is area of the segment. From this sector area A, O, A and B, this sector area, subtract the area of a segment. We consider this as a segment. Okay. So what is area of this segment? Area of this segment is, we have to find area of the sector, subtract these two areas. From the sector area, C, A, and B from this whole sector area. If you subtract these two triangle area, you will get the area of a segment. Now make another equation that area of segment is equals to area of sector CAB, this sector C, A, and then B. This is a sector of a circle with the center C. The radius is capital R, right? Okay. And subtract the area of two triangles. Subtract area of two triangles. These two triangles are symmetrical, right? So first thing first, we need to figure out the area of a segment first, right? So area of the segment would be area of segment, that is area of a sector C, A, and B. This is a sector, right? So area of a sector is half radius square theta. So half radius square is capital R square. And what is theta? Theta is this angle. For this sector, this angle is theta, which is 0.7, and this is also 0.7. 0.7 plus 0.7 is 0.14, right? So area of a sector is half radius square and theta is 0.14. Area of a sector, right? Area of this sector C, A, and B, right? Half radius R square and theta is 0.14, right? Okay, so what is R? R is 1.53 small r. Let me write it down. So, okay, first let me finish it out, right? 2 times area of a triangle is half AB sine C. Okay, if I consider this triangle A, O, and C, so these two sides are R and R and sine of the angle between them. So the AB and sine C. So R into R and sine of 1.74. This one is also the same because they are symmetrical. R sine of angle between them. So we consider this as two triangles, right? Okay. So now we have to figure out 1 over 2. R value is 1.53 small r square 0.14. This 2 and this 2 is cancelled out, minus r square and sine of 1.74. Okay. Now the segment area, we can say this is 1.53 square multiply 0.14 divided by 2. This would be 0.164 r square minus, what is sine of 1.74? 0.986 r square. Up to 3 decimal place I simplified, right? 0.164 minus 0.986, this would be negative 0.822 r square, right? Okay, now this is area of a segment. Now let me substitute the area of a segment over here. This implies shaded area becomes area of a sector AOB. So what is this sector? Area of a sector AOB, half radius square and theta is 2.8. Area of a sector is half radius is r square and theta is 2.8 minus the segment area is negative 0.822 r square. This is a segment area. Okay, now we have 2.8 divided by 2 is 1.4. 1.4 r square and plus negative times negative is positive 0.822 r square. So simplify the coefficient of r square, which is 0.822, and this becomes, wait a second, I did a mistake over here. This angle mistake, sorry. This angle is a sum of 0.7 and 0.7, right? So the sum of 0.7 and 0.7 is 1.4, not 0.14. That was the mistake, right? So this is 1.4. 1.4. So if I simplify this, 1.53 square times 1.4 and divided by 2, this is 1.64, right? And 1.64 subtract with 0.986, this becomes 0.653. So it's 1.4 over here, and when you simplify 1.64 and when you subtract both of them, this is 0.65 and round to 3. And after at the end, when we do 1.4 subtract 0.653, this becomes 0.747 r square. This is 0.747 r square. This is the shaded area in terms of r. That is the final answer. All right. Question number 11. The diagram shows the part of the curve with equation. This is the equation of the curve. The line x equals to 1 and x is equals to 2. These two line x equals to 1 and x is equals to 2 intersect the curve at P and Q. These lines intersect the curve at point P and Q respectively, and R is the stationary point of the curve. Stationary point, basically the turning point of the curve. Part A, verify the x coordinate of R is 3 by 2 and find y coordinate of R. We need to verify the x coordinate and solve for the y coordinate. Okay, so for stationary point, what we have to do, we have to put the first derivative dy over dx is equals to 0, right? So what is your function y? Y is x plus 2 into 2x minus 1 to the power minus 2. And let me solve for dy over dx. dy over dx is x derivative is 1. 2 is a constant term. Applying the power rule of differentiation, the power base function power minus 1, and the derivative of base function is just 2. Okay, so dy over dx, this is 1, 2, 2 and 2, so it's negative 8, 2x minus 1 to the power negative 3. Okay, now for stationary point we can say the first derivative is equals to 0. This would be equals to 0, right? Now negative 8 over 2x minus 1 whole cube would shift to 1, shift on the other side negative 1. So this negative sign cancelled with the negative sign. Cross multiplied 8 equals to 2x minus 1 whole cube. This term multiplying with 1. Okay, 8 is a cube of 2 cube equals to 2x minus 1 whole cube, right? Taking a cube root on both sides. Okay, so when we do the cube root, cube in the cube root is cancelled out. We are left with 2 is equals to 2x minus 1. So 2 plus 1 would be equals to 2x. Just shift the 1 on the other side becomes positive 1. 3 divided by 2 is x. So this is verified that the x coordinate of the stationary point is 3 by 2. X coordinate should be 3 by 2. So x coordinate is verified. Now we have to solve for the y coordinate by substituting the x coordinate into the equation of curve and solve for the y coordinate. Now put x is equals to 3 by 2 in equation of curve. So the equation of curve is y equals to x plus 2 over 2x minus 1 whole square. Okay, let me substitute it over here. So y would be equals to x is 3 by 2 plus 2 divides 2 into 3 by 2 minus 1 whole square. So this 2 and 2 is cancelled out. 3 minus 1 is 2. So y is equals to 3 by 2 plus 2 over this is 2 square. Okay, y would be equals to 3 by 2 plus 2 over 4. 2 times 1 is 2, 2 times 2 is 4. So the y coordinate is 3 by 2 plus 1 by 2. So 3 plus 1, when the bases are same, just add the numerator. 3 plus 1 is 4. 4 divided by 2, 2 times 2 is 4. So the y coordinate is 2. For the stationary point, the y coordinate is 2. Now the coordinates of the stationary points, x coordinate is 3 by 2 and the y coordinate is 2. Now for part B, find the exact value of the area of the shaded region. Exact value means it should be in fraction, so not in terms of decimal, right? The area of the shaded region. Now look at the shaded region. This is a shaded region. This shaded region is between the line PQ and the curve. Okay, so when we have area between the line and the curve, we do area of a line subtract area of the curve. Okay, so for curve we use the limit from 1 to 2, but what is the equation of line PQ? First we need to figure out the equation of line PQ. So P has x coordinate 1, we don't know the y coordinate for P. Q has x coordinate 2, but we don't know the y coordinate for Q. So let me solve for the coordinates of P and Q. Okay, so coordinates of P and Q. This is the first thing we need to solve. So when x is equals to 1, so as you know that for P the x coordinate is 1. For P the x value is 1, we need to solve for y. So just substitute x equals to 1 into the equation and solve for y. So from here the y would be equals to 1 plus 2 over 2 minus 1 whole square, which is 2 minus 1. 2 minus 1 is 1. 1 square is 1 and 2 by 1 is 2 plus 1, which is 3. The y coordinate is 3. So now the coordinates of P are 1 and 3. Okay, now let me solve for the the coordinates of Q. When x value is 2, what is your y? Y is equals to 2 plus 2 over 2 times 2 minus 1 whole square. Okay, so now 2 times 2 is 4 and 4 take away 1 is 3 and 3 square is 9, and what is 2 by 9 and plus 2 is 20 over 9. 20 over 9 or 2.22. These are the coordinates for y coordinate of Q. Now for Q we can say the x coordinate is 2 and the y coordinate is 20 over 9. Okay. Now we have done with the coordinates of P and Q. We can easily find out the equation of line PQ when we have two coordinates, right? Okay. For equation of line PQ, the first thing we need is the gradient of PQ, right? Gradient of PQ, which is y2 minus y1, 20 over 9 minus 3 over x2 minus x1, 2 over minus 1. Okay. Now this is 20 divided by 9, subtract 3, which is minus 7 over 9, and 2 minus 1 is just 1. So minus 7 by 9 is the gradient of the line PQ. Now let me solve for the equation of the line PQ, which is y equals to mx plus c. Y equals to m is minus 7 over 9x plus c. To get the c value, you can use the coordinates of p or the coordinates of q. This is up to you. So if I use a coordinate of p, which is 1, 3, y is 3, the x value is 1 plus c. So 3 plus 7 over 9, this is your c. Okay, so 3 plus 7 by 9 is 34 over 9. The c value is 34 over 9. Now finally we can say the equation of line PQ is y equals to minus 7 over 9x plus 34 over 9. This is the equation of line PQ, right? Now to get the exact area between the line and this curve, we have to integrate the line from 1 to 2, subtract the integrate the curve from 1 to 2. Here we can say area between line and curve. So integration from 1 to 2 of line. So equation of line is this. Let me integrate this line. If I can write it down. Minus 7 over 9x plus 34 over 9 with respect to dx minus integration from 1 to 2 of the curve x plus 2 over 2x minus 1 whole square dx, because line is at the top and curve is at the bottom. And when we have curve is at the top and line is at the bottom, then we do curve minus line. Now let's do the integration. Minus 7 by 9 x integration is x to the power 2 by 2 plus 34 over 9 x. The limits are from 1 to 2 minus here x square divided by 2 plus 2. Here we apply the power rule, right? So 2x minus 1, its power is negative 2 plus 1 over negative 2 plus 1 multiply 1 over the derivative of this function is 2 from 1 to 2. What I did over here, 2 is a constant. Basically, I shift this to the numerator. So its power is negative 2, applying the power rule of integration. So the function power plus 1 divides power plus 1, multiply 1 over the derivative of this function is just 2. Further simplify, which is minus 7 over 2 times 9 is 18x square plus 34 over 9x. The limits are from 1 to 2. Subtract, this is x square divided by 2. This 2 and this 2 is cancelled out, plus we have 2x minus 1 to the power negative 1 over negative 1. The limits are from 1 to 2. So here minus 7 over 18x square plus 34 over 9x, applying the limits from 2 to minus x square divided by 2 and minus 1 over 2x minus 1 from 1 to 2. Okay, now let me apply the limits. I can say now after applying limits, we will get the area. The upper limit is 2 and the lower limit is 1. Minus 7 over 18, 2 square plus 34 over 9, 2. Upper limit, subtract the lower limit is minus 7 over 18 plus 34 over 9 because it is just 1, right? This is for the first function. Subtract for the second function is upper limit is 2, so 2 square divided by 2 minus 1 over 2 times 2 minus 1. This is the upper limit. Subtract the lower limit is 1 square is 1 over 2 minus 1 over 2 minus 1. Okay. Now further simplify, the area becomes, okay, right, minus 7 divided by 18 multiply 2 square is negative 14 over 9, and 34 divided by 9 multiplied by 2, which is 68 over 9. Next thing, simplified, we can simplify, yeah, 34 divided by 9 and then subtract 7 over 18, 61 over 18, negative 61 over 18, minus, simplify this, 2 square divided by 2 is just 2, and 2 times 2 minus 1, so 1 over 3, minus 1 by 3. And here we have 1 by 2, subtract, this is 2 minus 1 is 1, just 1, minus minus plus 1 over 2. This negative and this negative is positive, right? Okay. 48 divided by 68 over 9 minus 14 over 9 is 6, and subtract 61 over 18, 47 over 18. Okay, now 2 minus 1 over 3 and plus 1 by 2. is 13 over 6 with a negative sign. 47 over 18 subtract 13 divided by 6 is 4 by 9. This is the exact area of the shaded region. 4 by 9 square units. All right. So that was the last question of our paper. If you have any queries, please let me know in our comment section. And please subscribe to my channel. Thank you for watching. See you next time. Take care.